Hello everyone, welcome to EasyElectronics. So we are discussing about the objective pattern for the first paper, Semiconductor Devices and Basic Electronic Systems. And I think we had already discussed the very first unit of it, objective question based on the first unit, which was the semiconductor diodes. And today we are going to discuss the objective questions based on the second unit, which is bipolar junction transistor BJT. And then we will move forward with the upcoming units also. So in this unit we had discussed about the BJT, its types, construction, principle, various transistor amplifier configurations, its input and output characteristics, how we are going to bias the transistor. One of the very popularly used transistor biasing is the potential divider bias, that was also discussed. And then we had seen the circuit of transistor as an amplifier, in which the concept of gain and bandwidth was seen. And at last we had discussed the transistor as a switch circuit. Okay, so we have to discuss the objective questions based on these topics only. So let us start with it. So the very first question is, an arrow of emitter indicates dash current flowing through emitter base junction. Options are conventional, normal, forward and reverse. This is the symbol of BJT for PNP and NPN, and we know that for PNP transistor the arrow of the emitter is in the inward direction, whereas in case of NPN this arrow is at the outward direction. And this arrow is indicating the direction of conventional current source. So option A is the correct one. Then in common emitter amplifier, input is in dash as compared to the output. So we are discussing about the common emitter configuration, and we know that here emitter is made common, and this is how the circuit of common emitter looks like. And whatever input signal we are giving to this configuration, at the output we will get it's exactly it's amplified signal, but it is in opposite phase. So at the output we are not getting the waveform like this, the waveforms are in the opposite phase like this. So this is the exact output, and that's why answer is in the opposite phase, that is in 180 degree. There is 180 degree phase shift between that of the input and output. Then the third one is, the emitter current flows through collector except very few through. So these are the options, and this is the structure of the transistor BJT, where this is the emitter section, this is the base section, and this is the collector section. And we know that whenever the current is passing through the BJT, it is due to the majority charge carriers, and whenever the current is flowing, then that is flowing through the individual section. So emitter current is the is having the highest value because it is highly doped section, and then it goes to the collector, and while going through the collector it is moving through the base section. As base is very lightly doped, so very small amount of current flows through it, and collector is moderately doped, so IC is somewhat less than IE current. So the correct option is option D, base. The semiconductor materials used to construct transistors are silicon or, so we know that mostly we are using silicon or germanium because these are the materials which are having the 4 electrons at their last shells. So see, this is the structure of silicon and germanium. So most probably they are used for making or constructing the semiconductor materials, because We know that semiconductor is having the properties of both conductor and insulator, and that's why this type of structure must be there. So the correct option is option B, germanium. Then use of transistor as a switch is advantageous because it gives noiseless operation, it is cheaper, it is attractive, it provides preciseness. So one of the advantage of using transistor as a switch, the circuit is shown here. So as a switch, whenever we are discussing, then we know that we are getting the two states, that is on and off. In the on state, current can flow through the circuit, whereas in the off state, current cannot. Now the option for this question is, correct option is, it gives noiseless operation. So transistor as a switch gives noiseless operation. This is one of the advantage of it. The most stabilized bias scheme for transistor amplifier is collector feedback, emitter feedback, voltage divider and fixed voltage. And the correct option is voltage divider biasing or potential divider bias scheme is most stabilized scheme for transistor amplifier. And this is the circuit diagram for potential divider or voltage divider biasing of transistor. We are just simply using one transistor and to it we are connecting 4 resistors and one supply voltage. Then when used as an amplifier, the transistor operates in dash. So options are cutoff region, active region, saturation region and breakdown region. So whenever we are using transistor as an amplifier, then it is operating in the active region. This is the correct answer, and this is the correct active region. This is the output Vi characteristic of transistor. This is the saturation region. This is the saturation region. This is the cutoff region. This one, and then the region above that of the cutoff region is the active region where the transistor is the transistor can be worked as an amplifier. To operate BJT in saturation region, biasing of the two junctions should be. So again, whenever we are operating BJT in saturation region, then both the junctions should be forward bias. So correct option is option A. In saturation region, both the junctions of the BJT are in forward bias. In cutoff region, both the junctions are in reverse bias, whereas in active region, the input section of BJT is forward and output section is reverse biased. So that's why the correct answer for saturation region is option A. The arrow in the symbol of transistor represents the terminal called as. So as we know that BJT is having 3 terminals, that is collector, base and emitter, and the arrow which is shown for the direction of the conventional current, that is uh, actually shown at the emitter terminal. So this is the emitter terminal. For PNP the arrow is inwards, in the inwards direction, and for NPN this arrow is having the outward direction. This is the only difference between the symbol of NPN and PNP transistor. So that's why correct option is option C, emitter. The physical dimension of collector region is. So the collector region is the largest region of BJT, which you can see here. This is having the big size, then emitter size is moderate, and then base is very thin. This is about the size. But if we are talking about the doping density, then emitter's doping density is highest, collector's doping density is moderate, and base is again lightly doped. So the size of the collector is large, but its doping density is moderate. So here we are talking about the physical dimension of collector. So that's why option A is the correct one. It is largest with respect to base and emitter. Which of the statement is true? CE configuration has lower input and output resistances. CC configuration has higher input and output resistances. CB configuration has high input resistance and low output resistance. And option D is none of the above. So the correct option is none of the above, because CE is the common emitter configuration, CC is the common collector configuration, and CB is the common base configuration. And all the three of these configurations are different from each other. When we had discussed the comparison between these three, then we had discussed about their input and output resistances. That is very different from each other. So please, if you want to go through the differentiation between these three, then you can just click on the I button and can go through that video where you will get the answers, correct answers of the input resistances for each and every configuration, input and output resistances. A germanium transistor's collector current is 15 milliampere when the base current is 0.4 milliampere. Find alpha and beta of the transistor. So alpha is the current gain in CB configuration or CB mode, and beta is the current gain in CE mode. So that's why we must know the formula of beta and alpha. So CB matlab common base, and that's why it is the ratio of output current, which is collector current, upon input current IE, and beta is common emitter, so the output current is IC and input current is IB. Okay, now here the value of IC is given, which is 15 milliampere, and base current is also given, which is 0.4 milliampere. Okay, so either we can find out beta first by using this formula, okay, and then by using the relation between alpha and beta. Okay, so from that relation we can find out alpha, or we can just calculate the value of emitter current by using this formula, which is IE equals to IB plus IC, and then simply put the values of each and every current in these formulas and we will get the answer. So after doing this, the answer that we are getting will be this one, option D, alpha equals to 0.97 and beta equals to 37.5. So there are various way of calculating various quantities. Only thing is that you should be aware of their formulas, and just remember that the current gain is having no unit. It is the unitless quantity because it is the ratio of two similar quantities. For a transistor, alpha equals to 0.96 and 0.96, find the value of beta. So as I told you, there is a relation between alpha and beta, that is alpha equals to, so that relationship is alpha equals to beta upon 1 plus beta. So, or we can say that beta equals to alpha upon 1 minus alpha. You can just put the values, and after putting it, yes, these are the relationship which is shown here, and how we can derive the relationship, that procedure is also shown. So just put the values and the answer is beta equals to 24. Option C is the correct one. Then in NPN transistor, the emitter current flows out of emitter terminal into emitter, neither in or out, none of the above. So NPN, as I told you, the direction is outwards, so it is flowing out of the NPN C. In the symbol only we are showing the direction of conventional current, so it is in the outward direction, so that's why out of emitter terminal is the correct option. Whereas in case of PNP it is asked, then PNP में this is the emitter terminal and the arrow is inward direction, so that's why we can say that the conventional current is flowing into the emitter terminal in case of PNP, but for NPN it is out of emitter terminal. Current amplification factor in CE configuration is just so we are discussing the current amplification in CE configuration and it is denoted by beta. So the current configuration in CB is denoted by alpha, CE denoted by beta, and for CC denoted by gamma. So whenever we are saying configuration, then that means we are making one out of the three terminal common. So in case of the CE configuration, the one emitter terminal you can see here, which is made common. So this is for the PNP transistor and this is for the NPN transistor. Emitter is made common and that's why it is called as the common emitter connection. And here the current gain is denoted by beta, which is actually the ratio of output current IC upon input current IB. And the current gain is the unitless quantity because it is the ratio of two similar things. The collector current is maximum in dash cutoff active saturation. So the collector current is maximum here. These are the three regions and it is maximum in the saturation region that you can see here. Here we are getting the maximum collector current in this region, which is the saturation region. Which of the following is a current controlled device? BJT, diode, MOSFET, and all of the above. So we know that BJT is one of the current control device, while diode is a simple PN junction diode. It is not controlling the flow of the current. MOSFET is the voltage controlled or electric field control device. So that's why the correct answer is BJT. Which of the device requires careful handling? So whenever we are handling any type of electronic instrument or components, then all of them requires very careful handling, because if we are handling them very robustly, then that will lead to the damage of them, because they are having very delicate terminals or delicate parts. So that's why all of the above is the correct answer. The collector region is made physically larger than emitter region because it is convenient, it is to be connected to output, it collects electron to dissipate heat generated. So the collector region is made physically larger for dissipating the heat generated. So this is the region, this is the reason why this region is made physically larger. So जो भी एक्स्ट्रा अमाउंट ऑफ हीट डिसिपेट होती है, तो उसको जनरेट जो हीट होती है उसको डिसिपेट करने के लिए कलेक्टर रीजन को फिजिकली लार्जर बनाया गया है. In ideal case, the input resistance Rs for voltage amplifier is low, high, zero, unpredictable. So in ideal case, this is the voltage amplifier, and here the Rs, which is the series resistance, it is having the high value. This is the series resistance. So ideally the value of this must be high. To operate a transistor in the active region, it is essential to give a forward bias to dash. So as I told you, active region mein input section is forward and output is reverse. So now it depends on which in which region you are, in which configuration you are operating the transistor. Now mostly we are operating the transistor in the CE configuration. So here we will say that the emitter junction must be forward bias. for the transistor to operate in the active region. A transistor which is used as a switch is known as a switching transistor, electrical transistor, BJT, mechanical transistor. So this type of transistor, it is called as the switching transistor. Voltage gain in decibel is expressed as dB. So it is expressed as the option C, 20 log at base 10 V out upon V in. So whenever, as I told you, gain is the unitless quantity, but it can be expressed in decibel, and depends that you have to express it as voltage gain or current gain or power gain. So there are various formulas for each and every gain, and for voltage gain in dB the formula is option C. The range of frequency over which the gain is equal to dash percent of the maximum gain is known as bandwidth. Now these are the various options, and this is the bandwidth, where the range of the frequency where we are actually getting this C, 0.707 of maximum gain. But here we are dealing with the percentage, not the value. So that's why it leads to into 100, 0.707 into 100. So it will become option B, 70.7% of the maximum gain. So such type, that range of the frequencies is called as the bandwidth. So bandwidth is most of the time that taken as the difference between this upper cutoff frequency and this lower cutoff frequency. So if in percentage it is asked, then this is the correct answer, and if there is no percentage, then you can write this option. If base current changes by 10 microampere, the collector current changes by 3 milliampere. Find the current amplification factor. So the formula of the current amplification factor is this: beta equals to delta IC upon delta IB. Just put the values and you will get the answer. So option D is the correct one, 300.